It's time to take it to the limit. Limits. Math joke of the day. All right. Moving on. Let's do this. So, get some new wonderful notation here. So, let's read this first one here. It says, the limit as x approaches 2. Okay? The limit as x approaches 2. What does f of x approach? Okay? So, as we're going along here, if I were to trace this with, say, we'll go with a bright color. Whee! Coming here from the left-hand side, I'm approaching this spot right here. As x approaches 2, f of x is approaching 1. And does the same occur from the other side here? Whee! It does. All right, so as x approaches 2, f of x approaches 1. So the limit as x approaches 2 of f of x is 1. Now, what is f of 2? You've done that many times, right? F of 2, the function value at x equals 2 is also 1 in this case. It's not always going to be the same. Okay? Let's take a look at the next one. The limit, once again, as x approaches 2. If I'm coming from each side here, from both sides here, that graph is approaching 1. Right? As x approaches 2, f of x is approaching 1. Okay. Now, what's f of 2? Well, there's a hole there, right? So, and there's no other point, so it does not exist. So even though the function cannot be evaluated at 2, the limit as x approaches 2 is still 1. They're approaching from the same thing from both sides. Now, the last one here, the limit as x approaches 2 of f of x. Again, I'm approaching the same thing from the left and the right here, right? It's 1. But f of 2, so the function when evaluated at x equals 2 is actually 3. Do we see that point up top here? There it is. So f of 2 is 3, but the limit as x approaches 2 is 1. Okay, so let's do some examples here. So we have the limit, and we're going to be using that graph over there on the left-hand side. The limit as x approaches 1 of f of x. Well, as x approaches 1, we're talking about that spot right there. So x would be, or so that would be negative 1. All right. As x approaches 1, function value is negative 1. All right. The next one. What's f of negative 3? F of negative 3, that would be the function at x equals negative 3, not the limit, but at negative 3. When evaluated at negative 3, that would be our 0 right there. That's what that solid dot is. Okay. And I'm actually going to jump down to number 8 here real quick. As x approaches negative 3, the limit as x approaches negative 3, that would be that would be positive 1. Okay, so again, although f of negative 3 is 0, the limit as x approaches negative 3 is actually different. It's 1. Okay. Number 3, the limit of f of x as x approaches 2. So as x approaches 2, it's approaching the same thing from the left and the right there. It is positive 2. But what is f of 2? Well, f of 2 is a hole, but above it we have a point that would be 3. What about f of 1? F of 1, there's a hole there, and there's no other point on the graph like we had at f of 2. So this one does not exist. There's nothing there. What is f of negative 2? F of negative 2, well, that's this point right here. That'd be positive 2. And then the last one there, as x approaches 0. So what is the limit as x approaches 0? Well, x approaching 0 is right here. It is negative 2. Oops. There we go. I like it. Cool. Awesome. Not too bad so far. All right, given an interpretation of the statement, the limit as x limit of f of x as x approaches 7 equals 10. So as the inputs for f get closer to 7, right, our x values as they get closer to 7, whether that be from the left or from the right, the outputs get closer to 10. That's why we can have a different function value when we evaluate, like we had for f of negative 3. F of negative 3 was 0, but the limit as x approached negative 3 was positive 1. Because if you look at this little stretch right here, let me go back to pink so it shows up. as I'm getting closer, my values, as you see those little pink dots there, my outputs are getting closer to positive 1. And when I start up here, as I'm getting closer to negative 3 for my inputs, my outputs are getting closer to 1. Okay, so that's why my limit is 1. Hopefully that makes sense. I think that makes sense. But I'm the one saying it. All right. So a limit does not tell us the value of f of x, right? It just tells us what the function approaches. It could be that value. It might not be that value. So let's do a little true and false. F of 1 is equal to the limit of f of x as x approaches 1 in all cases. No, that is false. Sometimes it'll be true. Sometimes it won't. Just depends. We've had cases where it's true and cases where it's false already in our first little introduction here. True or false? The limit of f of 1 is not equal to the limit of f of x as x approaches 1. Again, it could be true, but it might not be true. That is false once again. Okay. Glad we have that covered. And that's it for this video. Whoop. Done. Nice and quick. Hope you guys enjoyed taking it to the limit, if you will. All right. Have a wonderful day. America, freedom, rock and roll. Costco. Riverdog Jane in the ground. Yo, Rob. See ya.